Of all the dreams we chase, Mars holds a unique power. It's a red beacon of possibility, a canvas for our greatest ambitions. The narrative is compelling. The next frontier, the escape hatch for humanity, the inevitable step in our evolution as explorers. But this story, for all its inspirational pull, might rest on a fundamental misunderstanding of the challenge. The brutal truth is that landing humans on Mars and bringing them home safely, let alone establishing settlement, may not be a difficult engineering problem. It might be an impossible one, prohibited by the unforgiving laws of physics and biology with any technology we can foresee. The central, deceptive illusion is one of proximity. Mars feels close. It's our neighbor, visible to the naked eye. But this neighbor is, at best, 140 times farther than the Moon. In space, distance isn't measured in miles alone, but in energy. The energy required to cross that void doesn't increase linearly. It explodes exponentially due to the tyrannical rocket equation. To accelerate your spacecraft, you need fuel. But that fuel has mass, so you need more fuel to push that fuel, and so on. A mission to Mars requires roughly double the velocity change of a Moon mission, which translates not to double the fuel, but potentially to 8 or 10 times the mass at launch. The spacecraft becomes almost entirely fuel, with a tiny, precious sliver reserved for human lives and their fragile support systems. This is the first insurmountable wall, the sheer physics-mandated tonnage of propellant needed simply to make the trip possible is staggering, perhaps prohibitive. Compounding this is the tyranny of time. With our best chemical rockets, the journey one way takes 6 to 9 months. A full mission, including a long stay to wait for planetary alignment, and the return trip spans 2.5 to 3 years. For context, the longest single human spaceflight is just over a year, and that was in low Earth orbit with a quick escape route home. A Mars crew would be utterly isolated, with no possibility of rescue or resupply. Every system, air, water, food, power, must function flawlessly for years. A single failed pump or a clogged filter isn't an inconvenience. It's a death sentence. The psychological toll of this isolation, confined to a tiny habitat with the same few people while staring at a lifeless world, is almost unimaginable. Yet, these pale before what may be the ultimate showstopper, radiation. Once we leave the protective cocoon of Earth's magnetic field, we are exposed to the full fury of deep space. A constant barrage of galactic cosmic rays, high-energy particles from distant supernovae, tears through matter. On a Mars mission, an astronaut would absorb a radiation dose that exceeds NASA's lifetime career safety limits. This isn't a minor increase in risk. It's a near guarantee of significantly elevated cancer rates, with models suggesting 1 in 20 astronauts would eventually die from mission-induced cancer. But the threat is more acute. Cosmic rays can cause immediate cognitive damage, harming memory and decision-making, the very faculties needed to survive. Shielding is woefully ineffective against these particles. They smash into shielding materials and create even more dangerous secondary radiation. There is no solution to this problem with known, practical technology. We are asking pioneers to accept not just risk, but a slow, probable poisoning. Landing on Mars presents another cliff edge. The planet's atmosphere is just 1% as thick as Earth's. It's enough to create fiery, violent heating during entry, but not enough to slow a heavy crew vehicle to a safe landing speed. We've landed 1-ton rovers with audacious, nail-biting systems like the Sky Crane. A crewed vehicle could mass 50 to 100 tons. The engineering required to softly land this behemoth on another world, using a complex dance of heat shields, supersonic retrorockets, and final landing engines, has never been attempted. One error in timing or one engine fault results in a catastrophic crash. This must work perfectly on the first attempt, with no human oversight from Earth, thanks to the multi-minute communication delay. Surviving on the surface is a perpetual crisis. Martian soil is toxic, laden with perchlorates that destroy human lungs. Fine, Abrasive dust infiltrates every seal and mechanism. You must manufacture breathable oxygen from the thin CO2 atmosphere, extract and purify water from frozen deposits, and either grow food in hostile conditions or rely on years of pack supplies. Power must be constant and immense. Dust storms can blot out the sun for months, crippling solar panels. This isn't living. It's a continuous, high-stakes struggle for survival inside a fragile bubble. Finally, there's the cruelest twist. Coming home is harder than going. To leave Mars, you need a fully fueled rocket. Hauling all that return fuel from Earth is a mass prohibition fantasy. Therefore, you must manufacture it on Mars from local resources, using automated factories sent ahead of time. This technology, called in situ resource utilization, ISRU, has never been demonstrated at scale on another world. The entire return journey, and thus the astronauts' lives, depends on this robotic chemical plant working flawlessly for years before they even arrive. If it fails, they're stranded forever. Assuming it works, they then must launch from Mars, another perilous first-attempt-only maneuver, and endure another 9-month radiation bath before facing the white-hot precision of Earth reentry, all while their bodies have been severely weakened by years of weightlessness and exposure. We send robots because they bypass all this. They need no air, fear no radiation, and require no return ticket. They are true Martian explorers. The dream of human footprints on Mars is a powerful myth, but it may remain just that, a myth. It is not a failure of imagination or courage that holds us back, but the stark, unyielding realities of our biology and the cold physics of the cosmos. The red planet may forever be a mirror, showing us not what we can conquer, but the profound and humbling limits of our condition. To reach for it with machines is a testament to our ingenuity. To believe we must send human bodies there may be a failure to accept the universe as it truly is.